So this is the second part of Review 6. In this part, Review 6B, we will be reviewing how to do simple division. And again, we will be using a method that is a little bit different than the method most often used in the United States. But the reason is I think it helps students really understand the process rather than just the mechanics of how to work a problem. So this method is called the partial quotients method. And then we'll be talking a little bit about what happens when you get a remainder. All right, so let's take a look. So this is the partial quotients method for division. So let's just remember a division problem. The number inside is called the dividend. The number outside is called the divisor. And the answer that you calculate is called the quotient. And anything left over is called a remainder. All right, so let's take a look at how this partial quotients method works. And remember that the root word of partial is part. So we will be calculating different parts of the final answer, and then we will be adding up the parts to get the final answer, the final quotient. So let's take a problem like 452 divided by 4. The way this method works is draw a column for your partial quotients, which I will label PQ for partial quotients, and then over here will be our workspace. So 452 divided by 4. Well, you could start off by saying 100 times this 4 gives you 400. And what you do here is write the 100 in the partial quotients column and bring the 400 all the way around here and subtract it from the dividend. When you do that, you end up with 52. And now it's like starting a new division problem. 52 divided by 4. Well, another way of writing that is the reverse. What times 4 equals 52? Well, we could take 12. 12 times 4 equals 48, and that works. It's not 52, but it's less than 52. So let's bring the 48 over here, and let's bring this 12 into the partial quotients column. And over here we'll subtract. So 12 minus 8 is 4. And now, 4 divided by 4, well, we know that's 1. So we have to write it over here in the workspace. The 1 goes in here. 1 times 4 is 4. The 4 comes around here, and we subtract it, and we get 0. This 1 needs to be here. Now, these are all part of the final quotient. To get the final quotient, let's add them. 100 plus 12 plus 1 is 113. So the final quotient would be 113 and a remainder of 0. So it works out evenly. 113 times 4 equals 452. So let's take a slightly different problem. Let's say 623 divided by 4. And again, we want to have our partial quotients column, and then we want to have our workspace over here. So in this example, let's just make up a little story. We have 623 flowers, okay? And we're going to put them together in bunches of 4. 4 flowers per bunch. Now, if we put them together in bunches of 4, how many bunches can we make? And we'll find that out by finding out the answer to 623 divided by 4. So we could start off again by saying that, well, we know that 100 times 4 equals 400. So the 100 goes into the partial quotient column, and the 400 comes over here. We subtract it from 623, and we get 223. Well, let's take 223 divided by 4. Let's just use 12 again. 12 times 4, put the 12 over here. 12 times 4 equals 48. We'll bring the 48 around here and subtract it from 223. And we have 75. So 75 divided by 4. Oh, we can use 12 again. 12 times 4, again, equals 48. Let's put this 12 in the partial quotients column and bring this 48 around here to subtract it. And we have 27. 27 divided by 4. Well, 6 times 4 is 24. 7 times 4 is 28, so that's too big. We'll have to use 6 times 4 and bring the 6 into the partial quotients column. Bring the 24 around here and subtract it from 27, and we have 3. So we have a remainder in this problem. The remainder equals 3. The remainder is what's left over because this is smaller than 4. So let's just first of all add up all the partial quotients to get the final quotient. 2 plus 2 is 4, and 6 are 10. Carry the 1, 1, 2, 3, and then the 1 here, we bring that down. So the final answer would be 130, remainder 3. And you could write that up here. There's another way to express or to show the remainder. And you can take and put it as a fraction using the divisor. It's 130 and 3/4. So what this means is, if we take 623 flowers and then divide them into 4 flowers per bunch, we can make 130 bunches of flowers. We're going to have 3 flowers left over. So we've already decided, though, that we're going to put them in bunches of 4. So 3 is not enough to make 1 more bunch of flowers. So we'll just have 3 flowers left over. Okay, 130, remainder 3. Now in this situation, because we were pretending that we had 623 flowers, the 3 that are left over, we can just give those away to a friend. But let's say that we had 623 children going on a trip. And we could put 4 children in each car. Well, what would we do with the remaining 3 children? Would we just say, sorry, but you can't go on the trip? No, we would say, well, we're going to need 130 cars, and then we're going to have 3 children left over, so we're going to need 1 more car to take these 3 children. So we'll need to add that as a whole car, 131 cars. So when you get a remainder, what you do with the remainder really depends upon what you're dividing and what the purpose is. And we'll talk about this a little bit more when we learn more about how to do word problems, sometimes called numbered stories. But for right now, I just want you to remember that the remainder is sometimes something you can ignore, like the 3 leftover flowers, and sometimes you cannot ignore it, like if you have 3 leftover children.